Hello, Jeff.
Okay, this is the end of the week. I've lost track of how many weeks so far. I think we're halfway done. Next week is your quiz and exam. Next week is your quiz and exam. So the, let's see, Tuesday, Thursday. So Tuesday, quiz. It'll be released the day before. And then exam would be Thursday, so it'll be released the day before as well. And then your homework is due as well as the exam on a week from today. And the due time would be when our class ends. It should be, the due time would be what, 8 o'clock? That'll be for your homework and your exam. It's due before, it's fine, but no later. And through Canvas for your homework as well as your group quiz. And the exam. Exam too, you got to do it through Canvas. So everything through Canvas, please. Jan, comments, announcements, questions?
Just a reminder that during the exam, I'm not available for answering even homework questions. And after your group quiz, in between the time that you've finished your group quiz and your exam, I can help you guys out, but I just can't during the exam time. And just remember, Gordon's there, he's bored. So if you guys have time in the mornings I think it's Monday and Wednesdays, right, Jeff? I never know.
I forgot to. I got to give him a call anyway, but yeah,
okay.
I don't.
Yeah. So does that mean that there won't be a tutoring session on Tuesday then if the group quiz gets released? So this one for today was the last one until we have the exam?
No, tutoring's okay. On just before for Tuesday, that's fine.
Okay.
Yeah,
that's fine.
Okay.
Yeah.
Thank you.
What can be is the next day, Wednesday. So from Wednesday at about 6 o'clock-ish. So Wednesday night and all day Thursday, Jan will not answer questions on homework/exam. Anytime you have access to the exam, she's not available to answer any questions. But during the group quiz, that's okay. I'm okay with her doing that. Anything else? Anybody else have a thought, announcement? Okay, today, let's see my assignment schedule here. Yeah, today you're going to have, we're going to wrap up chapter 6. And it looks like, Jan, remind me, but I've got it scheduled here that there's another baby quiz, 6-1, 6-2. Did we do that yesterday with the other class?
Out on Tuesday. Let me double check, but I think they did theirs.
We did a quiz on Tuesday.
Yeah.
Oh, well, maybe. Okay, so I have, let's see, quiz 5. You guys did quiz 5? I'll double check. I'll double check.
Yes, we did do quiz 5.
Well, then I've got that in the wrong date for you guys. Let me see.
I think you said we weren't going to do it last week, and then we did it.
Okay. I'm looking at my big screen here. Yeah, it looks like you're right. Quiz 5 is done. Okay, no quiz tonight. So I'm just wrapping up chapter 6, it appears. So let's get going. Just a little reminder, we were, the hard problems that you were doing probably the past 2 days was regards to trinomials, where the numerical coefficient like this one here is more than a 1. I think I'll do this one. Jan, you might have done this one. I'm going to do it anyway.
Yeah, I don't remember if I did that one for this class. I think I did it for the other class.
So you do greatest common factor, no greatest common factor. Grouping, nah. Trial and error, okay. The technique was 10 times 12. You get that 120. And so choices. Now, we're trying to pick choices for 120, so somehow I get 19. Now, yes, you could list them all out. I think that's what I did over here. Actually, I listed enough out to find the right one on this one. Isn't 30, didn't I say 6 and 5 could be it? But why pick 6 and 5 if I knew 2 and 15 was it? If you stumbled on it faster than listing them all out, then go for it. I'm looking for 19. So I'll start with 120, 1 and 120, that was weird. 1 and 120. I'll do this one better. 2 and 60, that's not it. 3 and 40, that's not it. 4 and 30, that's not it. When I say that's not it, of course, when you add it, that's 34. But if you subtract it, sometimes subtracting gets it to you. That's still not it. Let's see, 5 and something. I think it's 24. I'll double check here. Okay, so 120 divided by 5, 24. I think that's it. Because if I subtracted 5 from 24, I get 19. So here we go. You go 10x squared. Okay, so instead of 19, I'm going to write it as, let's see, 24 subtract 5. So plus 24x subtract 5x. That gives me 19 subtract 12. And then you do grouping. You think I should just put a parentheses right here? Good. Brooke's saying, absolutely not. She's not going to make that mistake. Somebody in this class is going to. I hope you don't. I hope it's not you. You, or even the one that's not seen. I hope it's not you. You go like plus here and then negative 5x, subtract 12, GCF. Let's see, 2 maybe? 2, yeah, 2. Let's try 2 and an x. There's my 5x plus a 12. I'll take the negative off here. So yeah, or you know, there's a 1 here as well. If you don't see it, it's invisible. I'll take a negative off. Negative times a positive is a negative still. And then we've got 5x, and that would be plus 12. Okay, and then last piece, write down the 5x plus 12 once, parentheses, and you get 2x subtract 1, and that should be our answer. It's pretty methodical. I'll say there, chap. It's pretty British, that's pretty bad. British methodical.
You don't sound British. I don't know what you sound.
Cheerio. That's just awful. Sorry, I don't mean to, offend. Everybody's worried about offending somebody else. Okay, fine.
You sounded Irish, actually.
I did, didn't I? It's the luck of the Irish.
Yeah.
Lucky Charms.
I was going to say that.
They're magically delicious. Well, okay, so you got the idea. I hope you do. So let's see what we got in 6.5. 6.5, that's a little blurry. Let's kind of pull it away. Try this again. There you go. All right, so these are the factoring techniques. This is new. That one's new. That's what I'm going to look at in the next section. There is another set of factoring methods, difference difference of two cubes, and then sum of two cubes. Okay, so there are these guys down here, it's all about cubes, but you're not doing these,
And I sent them an announcement yesterday to let them know to not do those on the homework.
I did see that, and thank you for letting us know that. Thank you. So it's just the difference of squares, which is the easiest factoring method of all of them. Easier than GCF, I believe. I think so. Easier than grouping? I think you'll find that's true. Easier than trial and error? Oh, oh yeah. Yeah. That's the easiest right here. Easiest. Right, let's see. 2. You need 2 terms. 2 terms. How many terms for this? 3 terms. How many terms for this? 4 terms. Yeah, this one here is not just because it's 2. It's because, I'll show you right here, because there's 2 terms. There's a difference. Squares, okay, got to be a perfect squared number. Why is this one easy? Well, because, okay, that's a 4. What other number could go right here? What's another perfect squared number, anybody? What could go right here? What's another? Say again?
8.
Yeah, 8's not a perfect squared number because perfect squared numbers mean you have the product of 2 numbers that are identical. 4 times 2 are not identical, so no. 8's not a perfect square. One more time?
6.
Okay, how can you get 6 with 2 numbers that are identical? Multiply.
3 or
25.
9.
man, I
So
don't
not 9.
Okay, now some of you are starting to get it. Right, so you can't do a 6. 6 doesn't work. 9 works because it's 3 times 3.
Oh, it's multiplication.
Right.
Oh, okay.
25 works. Someone said 25 because it's 5 times 5. See, perfect squares right here. Perfect squares. Let's see. I heard someone say 25. Someone said 9. That's a 4. Okay, how about 100? Is that a perfect square?
You said 3 would work, right?
Now, okay, give me 2 numbers.
Am I still confused?
Yeah, give me, okay. So Brandy, give me 2 numbers identically the same. So when you multiply them, they give you 3. Can you do it?
I don't know.
Okay, here, I'll ask a different question. Okay, Brandy, watch this. Give me 2 numbers that are identical. So when you multiply it, it gives you 100.
50.
No, 50 times 50 is not 100.
Sorry. 20. Oh. I don't know.
Okay, try another one.
Okay.
Give me 2 numbers identical that when you multiply them, it gives you 25. Multiply. That's the key thing, is multiply.
5?
Right, 5 and 5. 5 times, not 5 plus 5, but 5 times 5.
Yeah.
Okay, now I know you can do this one. Give me 2 numbers that are identical. Identical.
Oh, 10.
Right.
Yeah.
Do it. I know you can do it.
Got it.
Okay, so Brandy, give me a couple more numbers other than these 4. Give me a couple other numbers than these 4 right there that are.
Okay. Let's see. I don't know.
How about 16?
How about 16, Brandy? What do you think?
That would be, I don't know, that would be 32, right? So yeah, I don't know, I'm not 100% getting it yet.
Okay, so why'd you pick 16, Helene? Because you're right. Why'd you pick 16?
4 times 4.
Okay, so 4 times 4.
Oh, okay. So 36 would be 1, because 6
Right,
times 6.
there you go.
Okay,
Okay,
I got you now.
good
All right.
job. Good job. Okay. So what's another one, Brandy? Then I'll let you off the hook after one more.
Okay, 64.
Ding, ding, ding. Okay, so
All right, thank
got
you.
it. All right, so you're getting it. I thought I heard someone earlier say 1. What about 1? That's true.
1 times 1.
Right, 1 times 1. And even 0. 0 is a perfect square. 0 times 0. 1's a perfect square. 1 times 1, and so on. So as long as that number, or any number like a numerical coefficient in front, which that's a 1, as long as the numbers are perfect squares, then all you have to do is write out 2 parentheses. See, perfect squares, this is, hey, 2 times 2. Put one of the 2's here, the other 2 right here. Put one of the x's here, and the other x right there. And it's always 1 of each sign. Always 1 of each sign. Now you say, I don't believe you. Okay, good. I'm glad someone said that. I don't believe you. So we're going to FOIL. You're going to check this. Check. FOIL. Now I'm going to check when I FOIL, do I get back to the beginning right here? Okay, you got x squared, that's first, minus 2x, that's outer, plus 2x, that's inner, subtract 4, that's last. These cancel, and you're left with what you started with. You'll find out they're pretty fast. Once you get the idea, which I think Brooke and Helene are both feeling a little better. For instance, is 121 a perfect square? And you'd say, I don't know. So this is, that might not be as easy as like 25. You can do that in your head, your multiplication tables. So what do? You say, well, how about 9 times 9? I wonder if that's 121. No, but 81 is a perfect square. 10 times 10, yeah, that's 100. How about 11 times 11? 121. Oh, okay, so since it's a perfect square, I can do this. And it's a difference. It has to be a difference. It can't be a sum. Can not be a sum of S, Q, U, A, R. Can't be a sum of squares. Can't be a sum of squares. Cannot. But Jeff, you had a sum of cubes. You wrote over here sum of cubes, something that can happen over here, even though we're not going to do those. Why can we do a sum of cubes and not a sum of squares? See, sum of squares is not listed up here because you can't do it. It won't work. Hey, if something doesn't factor, what's the word you guys use?
Prime.
Right. Good for you, Melissa. All right. Prime. Okay. Well, this isn't prime because I get to go x and x, 11 and 11, a positive and negative. Done. That's it. Pretty fast.
I have a question.
Yes, good.
So if we wanted to use like a calculator, would we be able to do like square root of 21? Would that figure it out, or is that something different? Am I confusing them?
Good idea. Good idea. 121. Okay, so you go like this. Second square root. You have to find out how to use your calculator square root first. Got to make sure you know how to do that. 121. There you go.
Cool.
Someone said 6 earlier. Might have been Brandy or somebody else, but someone said, I wonder if 6 is a perfect square.
That's my favorite question of the semester.
So Melissa says, take the square root of it and see if it gives you a nice number, Brandy, or whoever had said 6 was their favorite. And you'd say, no. See, it has to be a nice number. Someone earlier, and it wasn't Brandy, but somebody else said 8. All right, well, try square root of 8. No.
It's a
How
perfect.
about 49? I don't know. Square root of 49. Yeah. 49 is a perfect square then. I don't know. How about 400? Well, I don't know. Square root of, how about 400? Is that a perfect square? Yeah. 20 times 20. Not 401? No. 420? No, probably not. So yeah, that's a good idea, Melissa. Good job. I like that.
Can
I
I
have a
just,
quick-
Thanks.
oh, I was just gonna add, like, put a little cheat in there for those of you that are using your iPhones as a calculator. If you go into your calculator and turn your phone sideways, the entire scientific calculator comes up.
I didn't know that. Are you serious? I didn't know that. Wow.
Yeah. So
So
go
I
to your
go to-
calculator.
Yes, that's true. And then you can find the square root of a number there, or even a cube root. I think there's on there. It has like everything. I've seen
Oh,
that.
it's the majority of us. Yeah. Well,
Yeah,
first, there you go.
You have to turn your calculator sideways, though.
Hey, Brooke, thank you
Yeah.
very much. I did not know that that was possible, and I've had my iPhone for several years, so thank you.
I have a 19-year-old who's at Berkeley. She taught me like probably a month ago.
Are you serious? If you did this way?
Yes. Go. You have your
Go.
lock screen.
You
You
have-
have your lock
You
screen
have to
on.
unlock your screen. You
Oh,
have to
hold it.
press your home button.
No, I found it. I turned.
There
I
you
just.
go.
Hey, that is cool. That's worth the price of admission right here. I learned
There you
something.
go.
Very cool.
Welcome to the party, everybody.
Yeah, baby. Yeah, very cool. I like that.
I have a question about the equation again,
Yes.
or whatever you call that. Does it matter where we put the positive and negative, the positive or negative in that? I mean, could it have been 11 plus x plus 11 and so forth and so on?
Doesn't matter, because you've got what's called the commutative property that says you can take two things that are multiplied and switch their positions. See, these are being multiplied right there. So that could be first, no problem. And that could be last. Yeah, it doesn't matter. Yeah, good question. Good question,
you.
guys. All right. Okay, so 4 and 9 are perfect squares. So it should be that you just go, don't do 4 and 1. These have to be identical. Oh, 2 and 2. And 3 and 3. And x and x. And does it matter where I put the plus, Helene?
It does not.
Well, there you go. She likes negative. She likes positives first. Okay, right there, positive first. So you can put your favorite sign first if you wanted to every time. Positive or negative, it doesn't matter. Ooh, this one's kind of interesting. It's got two variables. 100 and 81 are both perfect squares. Okay, so 10 and 10, x and x, 9 and 9, and y's. And Helene likes plus first and then negative second. Pretty good. Now, the one thing I haven't done with these three that I just did, A, B, and C, the one thing I did not verbalize is I didn't do what I said you should always do. Ask yourself the question, can you do GCF first? Can you do the greatest common factor? I just knew I couldn't, but you should ask. No, I can't. No GCF. No, no, no. No GCF. No, no, no. How about this one? Is there a greatest common factor here? Uh-oh. Remember what GCF means? Or what you're looking for?
2 goes into both of those.
2. Right. Okay, there you go. 2 goes into both. Yeah. Now, if you didn't do the GCF, you might look at this and say, hold it, that's not a perfect square. Hold it, you're right. Hold it, square root of 50. And you go, oh, I can't do that one, must be prime. No, you didn't do the GCF first. Oh, look at this. If you pull the 2 out and you look at what you have left over, you can go further. You don't want to stop. You can go further if you can. See, I can go further. So if you said this was prime, you'd be wrong because you could actually at least pull off a 2. But I can go farther. Farther, further, further, farther. I can go farther. I can go further. Probably farther is grammatically better. I can go farther. I can go further. Does it make a difference, you English majors?
I think it's
I think it's further.
I'm thinking.
6 of one, half a dozen of the other. Further
Thank you
or
very much.
farther?
I vote for you. I vote for that right there. Guerneville or Gurneyville? I'm sorry, all those who live in that city.
Guerneville, period.
Oh.
There's no,
Gurneyville. I mean,
no.
well, tomato or tomato?
Tomato.
Thank you. Yeah.
Let's call the whole thing off.
That's a song or something like that, isn't it? Yeah. You guys are funny. I'm going to do a negative first, Helene. Sorry.
That's okay.
Best answer right there. I'll do this one next. GCF, a 2. Okay, so that can't factor, meaning the inside in the parentheses cannot go any farther. Like this, I can't factor this one, and I can't continue with this one. I did something here. This one is prime, because I can't do a darn thing. That originally is not prime, because I was able to do something, but I can't go any farther. This is what you'd box right here. But this one, you'd say prime. And you'd say, Jeff, I don't get it. How come? And then Brooke would say, well, I think I can factor that. Brooke would say that. Not with that attitude, but I think why isn't it? Sorry, Brooke, I'm picking on you.
You're not far off for how I do my homework, so.
Well, why can't I do that? Why can't this be? And most of you would say, I think it's x plus 3, x plus 3. It looks like it should be x plus 3, x plus 3. And then I say, well, check it.
Because that would be x squared plus 3 squared, right?
This is not just x squared plus 3 squared. You're forgetting FOIL.
Then there would be a 3x. Okay.
Yeah, so that's not just this. It's x squared and a 3x and a 3x and a 9. You have something extra right here that this doesn't have. That's not correct. And you say, oh, okay, fine. Then we'll just go like this. This must be it here.
that, Jeff, please.
This must just be like plus and 3 and minus 3. Yeah, it must be that one. Well, yeah, the middle term will go away, but you get negative 9 here. Yeah, I want positive 9. Oh, well then, Jeff, you haven't tried this one. I said, oh, you're right. I haven't tried this one. Jeff did the both pluses and how about both minuses? Well, if you do the same thing, x squared minus 3x plus, I get the plus 9 and the x squared, but oh, I got something extra. You can't factor that. You cannot. Here, look at right, way up here. Cannot be the sum of squares. Where is, oh, right, way up here. Cannot be the sum of squares. This is prime, can't factor, prime. Prime, sum of squares is prime. And I have a feeling, we got too many bets going on, Jan. Oh, I'll just no bets. I'm just thinking of a feeling I'm going to put one of these on the group quiz and or the exam, something like that, ish. And someone's going to try to factor it. And the common mistake is that one. And they don't check it. So I have a feeling that someone in this class tonight is going to they're going to forget. Or they're not writing it down and not dog-earing it and saying, watch out, watch out. They'll
Or
just forget
highlight
to
it.
check it.
Highlight it.
That's, yes, you know, it's just an idea. Have a sheet of paper of all the things to watch out, a sheet of paper with different colors on it or highlighters that says, be careful of all these careless mistake kind of things. Watch out. Remember this one, you guys? This is chapter 5. Say x plus 3 quantity squared. Watch out. Watch out. Someone's going to make the mistake. It's not x squared plus 3 squared. It's not. But someone's going to think it is. They'll think it's x squared plus 9. They'll think it's that. But it's not. This is write it down twice and FOIL. This is that. That is that. Which turns out to be x squared plus 6x plus 9. Uh-oh, rats. I caught one or two of you. I don't do it to be mean. I'm just doing it to see if you learn something. You know, there's certain things that you make a mistake that you try to learn from your mistakes. And then you get to be better at it. That's most things in life, I think. Okay, 6-5 then. So let's see. Yeah, we're not doing this. See, it's called the difference of cubes. Difference of sum of cubes. Not doing. Not going here. Not going there.
Don't go there.
Don't go there. So scratch, scratch, scratch. Jan indicated to you guys, she sent out an email yesterday or last night that talked about this, and there were certain homework problems that dealt with this that you do not do. Well, you can do if you want, but you don't have to, because it's not going to be on the exam, nor is it on the group quiz. So why do it? There you go. That was 6.5. Yeah, just difference of squares. Sum of squares is prime, but difference of squares. Oh, let's see here.
I'm not finding it, so I'm going to send it out again. I thought I sent it out, but
Well, I got it.
okay. But maybe you got it for the first class.
I got 2 of them. I got 2 emails.
I
didn't check.
You did.
I got it.
It's in the messages.
Oh, okay.
I got it in my email and my messages, so I think you're good.
Okay, good.
Yeah.
She is good, isn't she? I agree. She's good.
Thank you.
You're welcome. Looking. Okay, here's one place. Sum of 2 squares cannot be factored. Can't be factored. There must have been some other place before that that identified it. Let's see. Difference of squares, fine. Oh, Helene, this is, see how they're doing it? You can do it that way or you can do it that way.
Perfect.
Your author talks about it too. Sum of squares. Well, here's the first time that I've seen it. Okay, right down at the bottom. There's a sum of squares right there. I don't see them putting like a little box about watch out for this. It just says factor the difference of this binomial can be this binomial can be factored further since it's the difference of Oh, okay, yeah. B. Oh, I gotta flip the page. Sorry, that's A. Okay, let's see, where are we? Okay. Note that the binomial is the sum of squares, and since we can write x squared plus 4 as x squared plus 2x, we might try doing it that, which is the mistake I'm saying somebody's going to make. Or we might do that. But if you check, you'd find out neither factors correctly. There you go. In both cases, the polynomial, okay, so you write prime. See, everything I do in the book. Probably there's more stuff in the book that I don't do that I hold you responsible for as well. Unless there's something I said don't, like the difference in sum of cubes, I don't hold you responsible. So, but other than that, everything else, I can glean things out of the book. I haven't done it for a while. I mean, specifically, I'm going to find something in the book. That's what I'm thinking. On an exam question, on a multiple choice true false, I'm going to find something in the book that's there they should have read, but I didn't put it in my packet. If they're reading the book, they should be aware of it. I should be looking. Jan, why don't I'll put that on you?
Oh, no.
You find me a couple.
Bad guy.
You find me a couple of them that I'll put on the final exam.
Oh my God.
Okay, find me a couple things. I don't know, we'll talk about it and see if it's worthy of. Yeah, that's something that they should know about. I verbalized it, but I didn't write it in my packet. Something in the book that's not in my packet, but that's very important. And maybe I might even give them a little hint, those that show up for class one day, and say, here's something to think about. It's in your textbook, but not in your packet. I mean, get your money's worth out of your book. Might as well use it a little bit more than just homework.
I'm getting the book out now. I'm going to start looking.
Yeah, there's your homework for the weekend. Oh, speaking of which, I need to go over something with you at the end of class tonight, Jan.
Okay.
So remind me. Thank you.
I might have to come back in because I'll be hopping over.
No, it's just right after. When we're all done, then there's no little baby quiz. Everybody's done unless they're sticking around, and it's an easy question, something easy for me to tell you. So.
Gotcha.
Okay, last section, chapter 6, 6.6. Now we're going to use our factoring to help us do something called solving. Earlier, recall. If it said solve, and it said 2x minus 1 is equal to 3. This is chapter 2. Baby kind of problem now for all of you. You add 1, divide by 2, easy. And I'd say, well, how do you know it's true? X is equal to 2, I think. How do you know X equals 2 really is an answer? And all of you would say, well, Jeff, you told us to plug it in somewhere. And I would say, where? And some of you would say, into the original. And one person would say, I'll plug it in anywhere I want. And I'll say, not a good idea. Into the original. In the original. Yeah. So you're trying to solve for X. These kind of problems like this one, it feels like this. AX squared plus BX plus C. Okay, see, notice it's set equal to 0. That's the important. You gotta have, is that a word? I don't know. I'm putting it as a word. Gotta have ZERO on the right hand side. You got to have 0 on the right hand side. A few of you might question and say, hey, Jeff, can I have the 0 on the left hand side? Kind of Helene says, can I do that? X minus 2, X plus 2, could it be X plus 2? So yeah, 0 could be on the left hand side. 0's got to be on one side or the other. I tend to advise you on the safe side to have all the variables on the left-hand side. I said that at the beginning of the semester, you just forgot. I've tried to advise you to do that because there's a place where, oh, hey, we already did it. Remember chapter 2? Well, I'm going to remind you. Remember, Jan, chapter 2, section 9? It's the inequalities. That's where the problems occurred in chapter 2. If you tried to not put the variable on the left hand, you put it on the right hand side, you could make a mistake. So I was trying to advise you to hopefully not make the careless mistake. I'm advising you to keep the 0 on the right hand side. That's all. So look at this. This got no 0 right here. So you got to move the 3. Okay, there it is. Oh, okay. Not finished yet, because now what you got to figure out is what answer or answers. You see the degree right there? Okay, there were questions that you were asked in homework in chapter 5 that says, hey, what's the degree of the trinomial? What's the degree of the polynomial? What's the degree? And you'd say 3, 2, what? I don't know. The degree of the polynomial is the highest degree term. That's 2, that's 1. And by the way, what's the degree of this term that I got my finger on right now? Anybody? What's the degree? I know you guys are gun shy.
0.
Right, good for you for saying it. Good for you. So in descending order of power, that's the highest. So it's called the degree 2 polynomial. So here it comes. The degree tells you how many answers you're supposed to find. It's true. The power or the degree, highest degree, tells you how many answers. I need to find 2 answers. I need to find 3 answers because that's a degree 3. 3 answers. 2 answers, 2 answers, 2. Oh, this one's got a problem. I got to move the 16 over eventually. Over there. That one's weird. 2 answers. 2 answers. Your job is to find the answers, and I just told you how many answers you're looking for. So I got no water. Oh, here, yes I do. So we make sure that the equation is set equal to 0, 0 on the right-hand side. Factor. Oh, okay, factor. GCF. Is there a GCF? Okay, I'm going down my list that I have mental right here. Number 2, grouping. Do I do grouping? No. Number 3, trial and error. Easy or hard one? Some people say they're all hard. I call this the easy one because there's a 1 out here in front. Easy, it's easier. Okay, factor, sure, okay. Then what you do is you set each factor equal to 0. X minus 3 equal to 0. X plus 1 is equal to 0. Solve individually, you get 2 answers. And how do I know they're correct? Yeah, check them. Okay, check my answers. Here's my check. Okay, here's the original. Okay, there's the original. All right, check. So I'll do the x equals 3 over here first. So that's 3 squared. Subtract 2 times 3. I wonder if that equals to 3. 9 subtract 6. Sure enough, check. It worked. Box my answer. Okay, so I'm going to do this one here. X equals -1. I wonder if that's true. Back up to here. Okay, now watch what I do. I call this sloppy math. I even told my Math 27 class today, Jan, about this. Sloppy. Okay, that's not a math word. That's Jeff's word. Sloppy math. And on the group quiz, if I see what I consider sloppy math, I'm going to mark you down. So I'm going to give you an example of sloppy math. So I go back up to here again. Hey, x squared. Okay, this is the mistake. -1 squared. That's not good. I call that sloppy math. Let me keep going for a second. -2. Usually you don't put a dot. You probably put a parentheses, -1. That's not a problem right there. Equals 3. So why is this sloppy? Well, mathematically, the way it's written, this is incorrect, by the way, but mathematically, you're only to square the 1 and not the negative. Chapter 5, section 1, when we talked about exponents, I gave you examples like this. As a matter of fact, they were with the 2's. I said, hey, what's -2 squared versus what's -2 squared? And we went over that. Check it out in my packet. That's -4. That's +4. If you wrote that and you said, well, I would have squared the negative anyway. It's supposed to be. I would have made it 1. That is the correct answer. It's supposed to be 1 because you're supposed to have a parentheses around it. That's the whole deal. See right here, you're supposed to have parentheses around it. But Jeff, I got the right answer at the end. I got the right check. Yeah, but on the group quiz, I'll check it. And if it's sloppy math, I'll take a point off because mathematically it's not right. You need to do this so that you can truly get the 1 that you're supposed to have. And then +2 equals 3. Sure enough, check. This is the right answer. Box. So I hope that makes sense about sloppy math. Gosh, the other culprit is typical one I get kind of picky on, but they're not getting it yet, Jan, is the quadratic formula. Aha, quadratic formula.
Oh, yeah.
Yeah, with big square root. I get picky on that. Here, you heard me say quadratic. Here's this word quadratic. Now, all of you taking beginning algebra right now, or it's been a while, this is your first time around or it's been a while, the word quadratic, rightfully so, sounds like it has something to do with 4. Quad, 4. Like trinomial is 3 terms and things like triangle is 3 angles, 3 sides. Quadrilateral is a 4-sided figure and things like that. But a quadratic quad has nothing to do with 4 for you guys, nothing. Someone just gave it a name and you got to deal with it. So if you want to, you could say solve the degree 2 equations or solve the degree 3 equations, because I had 1 on the other side. You could do that. Solve the polynomial equation. You guys had that phrase before. Oh, polynomial. Okay, there you go. Oh, there it is. Polynomials. Yeah, they're all polynomials. I like that. Solve the polynomial equations. Your author just calls them quadratics if they're degree 2. Quadratic equation is a degree 2. See, degree 2. Over here, this is not quadratic. This one here, no, not a quadratic. All the other ones are, even this weird one here. Yeah, I'm going to do this one tonight. Let's see, I'll do...
You do 1 and 3, Jeff.
One more time.
Let me do 1 and 3.
Yep.
Just because my book has room for that.
Your book has room for that.
Yeah, I only have 1 book and I use it for both classes. So.
Okay. Did you do number 7? Do you not have room for 7?
I could erase it and do it.
No, I don't need you to do that. Okay. What's my time? 7 o'clock. Yeah, I got time. Okay, so let's see. Okay, set equal to 0, yes, no. Oh, okay, 9, x squared minus. Okay, now it's a yes. Yes, yes, weird. Okay, so that's weird. I'll do the weird one first. Oh, yeah, you said you want to do these?
Yeah, I'll do one
Okay,
in.
so these are Jan. Okay, I'll do the weird one first. Here's what you need to do. You need to distribute first. So now we got, what is it? 2x squared subtract 7x is equal to 4. Okay, it's not so weird now. Kind of looks like this one did. You got to bring the 4 over. Okay, so it's not too bad. It's a trinomial. So 2 parentheses, oh, GCF, no. 2 parentheses, 2x and an x. Okay, now you have a choice. Okay, 4, this is the traditional method, not the grouping method. The British, not the British method. Traditional. Okay, 4 and 1, 2 and 2. 4 and 1, 2 and 2. Trial and error. I'm going to pick the correct one. 4 and 1. It's practice. You just got to practice and you'll get better at it. All right, 4 and 1. Where do I put the 4 and the 1? I'm going to put the 4 here and the 1 there because my eyeballs went to 8 and 1 in my mind. 8 and 1 is 7 somehow. 8 and 1. Because I've put the 4 right there. That's 4 and 2. 4 and 2. Anyway, give it a try. All the factoring, you'll get better at it. This one's got to be negative. This one's going to be positive. And then you take each one of these, set them equal to 0. X minus 4, set it equal to 0. This is x is equal to 4. All right, now this one has 2 steps to it. You get rid of the 2 first. You get rid of the 2 first. Which one? Yes, no. 2 first?
I'm gonna guess yes because you keep pointing at it.
Okay, so was that Brooke? Okay, good, Brooke. So
Damn it.
Jan, you're going to do, because I'm going to run out of room over here. You're going to do number
Okay.
6. You're going to do 6 as well. Okay, so you're doing 6 as well. Okay, so Brooke, here you go. 2x plus 1 is equal to 0. I'm glad you asked that, Brooke.
Oh no.
Oh,
You
yeah.
get rid of the 1 first.
No,
Well, never-
you
okay.
said get rid of the 2 first. You want to do
Yeah,
that.
but we're solving. Yeah, okay,
But
let's do
that's
this.
okay.
Fine.
You can do the 2 if you do it correctly. It'll work.
Are we
Okay,
doing
let's
the
go.
rule of PEMDAS for this?
No,
'Cause I was following PEMDAS.
no.
It's just
It's
division first.
PEMDAS reversed.
Oh,
No, don't do PEMDAS. So Brooke,
headache.
you want to get headache. Get rid of. How do you get rid of multiply? I'll help you, Brooke. Multiplying by 2. How do you get rid of multiplying by 2? How do you get rid of?
Divide.
Right. So what you do to one side, you do to the other. Remember that? What you do to one side, do to the other. So you're going to divide by 2 here and divide by 2. What you do to one side, do to the other. Now, what you don't want to do, Brooke, is just make that go away and ignore that one. You don't want to do that. So because I have this crazy fraction, you have to separate the fractions out. So it could be done. It's just most people will forget. They'll just think they'll divide the 2 and forget the 1. This is 0. Oh, and then how do you move the half, Brooke?
You. My mic's broken for some reason.
No, it's not. Yeah, right. Oh, she is so funny tonight. She is.
You can't see her. She's hiding.
Dude, I'm not even gonna lie. I'm so totally brain dead.
She is just a character. All right. So we're going to subtract a half. That's the process that Brooke was trying to say until her mic broke.
Right.
From
Subtract a half.
right. That's what. Oh, microphone came back on. Good. And then you've got x equals negative a half. Now, had you done it the other way, if you subtract 1 first, see there's the -1, and then divide by 2, you get the same thing. It's just one way is a little easier, less apt to make a mistake than the other way, but they both work. This one here is x equals 4. I'm not going to check them. They'll work. I'm not going to check them though. All right, I'll do number 7 next. How many solutions? There are 3 because of the degree. So GCF first. Take the 3 off and the x off and write down what's left over. And that's the difference of 2 squares. We just came off that section. Three answers, 3 parentheses. Take each parentheses and set it equal to 0. Divide by 3. Add 2. Subtract 2. It's all about factoring again. Chapter 7, after the next exam, chapter 7 is all about factoring again. Can't get away from it. Okay, Jan said should do 1, 3, and 6. So I'll do 2 and 4 next. I'll go backwards and do 4. Oh, this one, ooh, hard one. Thanks a lot, Jan. That's a hard one. Shoot. Okay, GCF. How about a 3? Yeah, somebody would say, how about a 3? 3 goes into 9 and 24. 3 doesn't go into 16, though. Oh, yeah, okay. Oh, these are even. How about a 2? But 2 doesn't go into 9. Yeah, there isn't anything. So no GCF. Rats. Trial and error. This is a hard one. I'm just going to do it just because of time. After you do the British method, yes, I would end up at the end getting this. If you did the British method. I'll show you. I'll check it. I didn't do the British method. I didn't do any method. I just knew what the answer was. When you do your method, you will get identical ones. That's what will happen. So let's see. I'll just check it. There's 12. There's 12. 24. 12 and 12 is 24. 4 times 4 is 16. 3 times 3 is 9. Yeah, looks like it's going to work. So you set that equal to 0. Well, you set, there's a copy. You go, do it again. Well, they're the same answer. In pre-calculus, there's probably just a few of you that are considering that direction. A few of you that are going to go or have to need pre-calc because you're going to calc. Why would you take pre-calculus if you're not going to calculus? I don't get that. I'm doing it for fun. I've had a couple students in my lifetime that says, I'm just doing it to learn. Okay, that's fine. But if you didn't have to, there's other classes you need to take. Most people are not math majors. Most are not. They're just doing it to get through. But if you took pre-calculus, you would have to, and my class today, I emphasize that you have to account for, yes, they're the same answer, but you have duplicates. You have to say something like, it's a duplicate. Very important. For you guys, you say, yeah, it's just the same answer. It's x is equal to 4/3. It's just the answer. There's only one unique answer, 4/3. Add 4, here it is. Add 4, divide by 3, or we'll say Brooks method.
That's me. Where did the negative go?
This one?
Yes.
Okay, so I'll do I'll do Jeff's method, and then we'll do Brooke's method.
It's the broken mic method. It's a
Oh, she muted herself.
Maybe she might really have a broken mic. Okay, so I'm not doing this one. Let's see, Jeff's method would be 3x minus 4. This is what Brooke is asking. Okay, so where did the negative 4 go? You went like this, Brooke. I want to make it go away, so I add 4 to both sides. And then divide by 3. So then I get okay, that's Jeff's method, which I think most of you would probably do it that way. Probably. But Brooke's method was, here's the same problem, because she wanted me and one of the other problems to get, like I was doing this. She says, well, it must be the 3 because you're pointing at it all the time. So I said, okay, Brooke, well, okay, that's not what I would do. So she wants to get rid of the 3 first. Remember that, Brooke?
I like Jeff's method better. So
Well, sorry,
I'm
you can't have it. You can't do it. Everybody else gets to.
No,
Your microphone's broken. Can't hear you. Hope you know that I'm messing with you, Brooke. I don't want to offend you at all. But.
Why? For reals, come on now. The sarcasm is thick. It's okay.
Okay.
I'm gonna live. We're all gonna live. There's comedy. It needs to be had. This is depressing and stressful. And I said in a breakout group at one point that I'm pretty sure that you are able to communicate with aliens based on everything that's on this screen right now. And I'm sure Elon Musk.
Elon Musk what?
I'm pretty sure Elon Musk would agree. In fact, that looks like his kid's name.
Oh, yeah. We can speak to aliens, Jan. You and you're at that level too. You can speak to the aliens.
Yeah, speak to them now.
Where I'm at right now.
This is all a foreign language beyond any Earthlings can talk
We
about.
actually are aliens. Let's just, if we unzip the human suit, you'd see.
Oh, here's a copy of one of Brooke's. Okay, remember that? We split it up into 2 fractions. So this is what she wants to do, or you should do, is 3x over 3 minus 4 over 3 equals 0 over 3, which is 0. Okay, and then these go away. And then you add 4/3 to both sides. Hey, we get the same answer. So we're patenting this.
I feel good about that.
We're patenting this, Brooke. You get whatever royalties we get from anybody using your method, I'll pass them on to you. You pay for your college education with Brooke's method. All right, so you get to use either one. Either, doesn't matter. You get to pick. And Jan, I'm going to throw another one at you. There you go. Number 2. So you get 1, 2, 3, and 6. 1, 2, 3, and 6. You just have to do the other ones on a scratch piece of paper if you don't mind.
I'm already writing them down.
Yeah, so 1, 2, 3, and 6. And I don't know if I left you anything on the difference of squares. I think I did them all. Yeah, I did them all.
Okay.
.7. Yeah, I don't have anything there. I have it in my packet. Did you notice if you flip over 1 or 2 more pages, there's a 6.7 section? Yes, you see that?
Yep.
No?
Pythagorean.
Yeah. Right, the Pythagorean. Okay, now you've heard of that before. And we will come back to it later on in the course. A squared plus B squared equals C squared. That's the formula most all of us remember, right triangles. So if we don't have a homework question or a exam question on it, you'll see it later on. So no 6.7, even though that's in the packet. And Jan, oh, here's an idea. If you wanted some more stuff to do tonight, Jan, if they need it. Yeah, I figured out, Jan, how to put numbers in my packet now.
On the pages?
Yeah, it was too easy. I just didn't have time to figure it out. So hopefully my packets, well, not hopefully, my packets moving forward for the spring, they'll all have page numbers now.
Right, and this is just the review. I see that page, Jeff.
Yeah. So pick some of these. There's some of them you won't do, like this one here, number 8. Number 8 you don't do. But all the other ones are good ones. So there's an idea too, as well.
Yeah, we need to.
Yeah.
Cool.
Okay.
Did you tell them about next Tuesday yet?
Yeah, I think I'm going to next Tuesday. It's not.
No.
Yeah, and I thought about what I made the announcement. It's way too far in advance.
Okay.
So I'm just gonna not.
Okay.
Yeah, not. Thanks for reminding me, but I'm not going to do that.
Okay.
Okay, so any comment from you guys? Not Brooke, because she can't. She's not allowed to. Donica, you'll be your turn on next week to be picked on. She's going, no. No.
I don't think I've heard Donica talk yet.
I think at the beginning of the semester. I know I can pick on John. John's a good sport. Yeah, there, right. See that? Yep. Okay. I didn't see that. You know, I have control of the grades, John. You know that.
Am I the only one who's finding these completely? I can't get this at all.
Yeah,
Am I the only one?
Which part? Which one, Helene?
The whole thing. This is a real. I mean, I just conquered what we did in the last section, and I felt really confident. And then I get into this section, and I don't know. I just was wondering if I'm the only one. If anybody else is having.
So what? Okay, so let's watch this on this review page that I've got, Helene. Cover this up with some. Okay, number 1. Oh, your eyeballs are going to go to that. Okay, number 1. Remember the factoring methods?
Yes.
Okay, so the first one you want to try is always which one, Helene?
Greatest common factor.
Okay, so do you think there is, and we don't have to tell me what it is, but just do you think there's a greatest common factor here?
Yes.
Good, okay. How about number 2? Is there a greatest common factor here?
No.
Good. How about number 3, greatest common factor?
No.
Number 4?
No.
Good. 5?
No.
6?
Yes.
Good. See, you're doing good so far. You're identified that there is a greatest common factor. Then you just have to be confident to pull it out and write down what's left over. I think you can do that. Okay, next step. Okay, so let's ignore this one. Number 2, no greatest common factor. What's the next choice down the list? Method number 2.
Grouping?
Right. So number 2, would you do grouping?
Yes.
Y. W-H-Y, not the letter Y, but W-H-Y.
Oh boy, I got myself into a quandary, didn't I?
No, that's good. Well, this is good because you're going to answer
Is your mic broken, Helene?
Yeah, hold it. Did I hear some scratch? Something was scratching
How's
out.
the audio on this?
My internet's going out. Well, maybe hers is.
Okay, so I know The only reason I said grouping was because it looked like one of the things I've just done that was grouping. I
Well,
don't
good.
know why, but it
Well,
looks like it.
What's different between this one and 3 and 4? What's different between?
Oh, there's more terms.
Right. How many terms total?
4.
Right. So anytime you have 4 terms, grouping.
Right.
Okay, let's go to number 3 and 4. Would you do grouping on 3 or 4?
No, that's going to be either trial and error, guess and check.
Right. I agree. Good, good, good. Okay. Any of these would you do possibly difference of squares? Any of these problems? Any problem? Would you do possibly difference of squares?
Oh, and difference of squares is if there's what do you call it when it's square? Is it cube? No, what's the word for it?
Perfect square?
Perfect square. Is that?
It'd be 7 and 8.
Okay, we're not doing 8. I'm scratching that one off. So, because that's got a cube on it. So, no 8. So 7. What? Whoever said 7 is right. 7 is the difference of squares problem. That's what we were doing tonight.
Squares.
Because, okay, when I say difference of squares, I think I put down on your packet difference of 2 squares. 2 squares. So if you have 2 terms, likely it's the difference of 2 squares, likely. Unless it's number 9, which, what do you say about number 9, Helene? What do you think number 9 might be? There's a special word, it's got a P in it.
Prime.
Right. This is prime immediately because prime, P-R-I-M-E. Sorry, Jan, I just took that one away from you. Or Helene did. Prime because it's the sum of squares. You can't factor the sum of squares. Cannot. So this one's the new one, Helene. That's the only new one. Well, these 2 are new ones, but that's a new one. You remember how to do this one, Helene, tonight? I bet you could try. And if you don't get it right, you'll learn from it.
Well, I think once I have a little time with Jan, maybe just a little bit more review, it might sink in.
Okay. I won't have you try that one, but this one's tonight. But I feel like if you've been practicing, number 10 you'd be able to do if you can. What if you can't factor this, by the way? Or any of them? What if you can't factor any of these? What's the word you would use, again, if you can't factor it all?
Is it prime?
Yeah, prime. So you just have to go through and say, gosh, if I can't factor that, it's prime. If I can't factor that, it's prime. Why would Jeff give me 12 problems or 10 problems? They're all prime. I wouldn't. So most of them can factor. One can't. There might be another one that's floating around that you can't factor. And you don't know until you try.
I think too, Helene, I think that on the 6.6, when it is equal to 0, I think that's kind of throwing you off. We'll do a little practice and I think you'll be less confused. The zeros on that side, but then basically all the stuff Jeff just showed you is on the right-hand side mostly. And so then we're just factoring and then trying to get our little parentheses to 0. So it's just that extra step.
Yeah, she'll go through that. This isn't practicing the solving. You might want to do more of those tonight, Jan.
Yeah,
You go there too.
Yeah.
That's an idea. That's a good idea.
Yeah.
Okay, let me stop this share. And if you want to stick around, you can do so. I'll answer questions. Otherwise, Jan's heading out.
Link in the chat, and Jeff has a question for me first, and then I'll be over there.
There you go.
Right, Jeff? You have a
Okay,
question?
yeah. Okay, I'm trying to think of what it was. Crap. I'm thinking. I didn't write it down.
Okay. Uh-oh.
Let me think. Shoot.
Everybody wants to hear what it is.
I know they're waiting. They're watching me
I
sweat.
have a quick question while
Yes.
you think about remembering what you're trying to remember. So I had a missed class on Tuesday and I went to the Zoom thing to see the recording and I don't see it. So I was just wondering if it takes some time to go on there or if I'm looking in the wrong spot.
So what happened over last week, including the weekend, is the campus, it was campus wide.
Yeah.
And we got a notification that said Zoom And in particular, Zoom was having an issue.
Okay.
If I'm
With-
going to go over to the other class and then
Okay, we'll talk later. We'll
Yeah.
talk later. Yeah. So Zoom was an issue. There was some
Okay.
issues with the technology, and it was some faculty says, "Hey, I've lost all my videos
Okay.
in Tech Connect Zoom or what. I've lost them all. I can't find them."
Mhm.
And the powers that be found them,
Okay.
and it was taking time to recover them.
Okay.
And so I would say, be patient. I'm going to look right now and see if I can
Okay.
find it.
I
And
just looked on my phone and I didn't see it yet either.
So was it this from Tuesday?
Yeah, so it would be the class from the 6th.
The 6th. Okay, give me a second. Let's see if I
Okay.
see it from my end.
Okay.
Let's see. Dashboard. I see something that says the 6th. Let me show you what I'm
Okay.
seeing.
Because maybe if I log on an actual desktop, that would be better and not on the app on my phone.
Could be.
Yeah.
That's possible. I'm going to go in as a student first because I want to make sure as a student we can see it versus a instructor, because I see it as an instructor. Tech Connect Zoom. I don't know if that's what you were looking. Yeah.
Yeah.
Click on that. You can go into cloud recordings right here.
Okay.
There's the 6th. So let me see if it's working.
Oh yeah. Okay, so it must be because I'm doing it on my phone, because I didn't even see that on my phone.
Oh, you didn't? Okay.
So I'll try from my desktop and hopefully that'll work.
Yeah, I'm seeing. Yeah, and I'm even seeing the transcripts over here, so it looks like it is going to work for you.
Okay.
So try your desktop. There you go.
Alrighty, I will try that. Thank you.
You're welcome.
Okay, bye.